That's centripetal acceleration. Hey there, science fans! Have you ever spun around until you felt dizzy? That feeling comes from something called centripetal acceleration. It's what makes objects move in a circle. Remember, acceleration is any change in speed or direction. When you go in a circle, you're always changing direction. That means you're always accelerating, even if your speed stays the same. Centripetal acceleration always points towards the center of the circle. It's like an invisible force pulling you inward. Without it, you'd fly off in a straight line. Think of swinging a ball on a string. The string provides the force that keeps the ball moving in a circle. That force creates the centripetal acceleration, pulling the ball towards the center. Centripetal acceleration is everywhere. It's a fundamental concept that you encounter in many everyday activities. It's at play when you're riding a carousel, whipping a lasso, or even just turning a corner on your bike. When you ride a carousel, the centripetal force keeps you moving in a circle. Similarly, when a cowboy swings a lasso, the rope creates a centripetal force that keeps the loop open. Ever noticed how you lean into a turn when riding your bike? This is your body's way of balancing the forces at play. That's because your body wants to keep going straight, but the friction between the tires and the road provides the centripetal force needed to turn. Without this friction, you would just skid outwards. Even the Earth's orbit around the Sun is due to centripetal acceleration. The gravitational pull of the Sun acts as the centripetal force. Gravity acts like a giant invisible string, pulling the Earth towards the Sun and keeping it in orbit. Think about roller coasters. When you go through a loop-the-loop, you feel heavier at the bottom and lighter at the top. This is because centripetal acceleration changes the force you feel from your seat. At the bottom of the loop, the force is greater due to the combined effect of gravity and centripetal acceleration. At the top of the loop, the force is less because gravity and centripetal acceleration are working in opposite directions. This interplay of forces is what makes the ride so thrilling. Here's the thing about centripetal acceleration. It's stronger when you go faster or turn in a tighter circle. Imagine driving a car. If you take a sharp turn at high speed, you feel a strong force pushing you outwards. That's because you need more centripetal acceleration to make that tight turn. The relationship between speed, radius, and centripetal acceleration is important. It helps engineers design safe roads, build thrilling roller coasters, and understand how planets move through space. The faster you go, or the tighter the turn, the more centripetal acceleration you need to stay on track. Ready for a little math? Don't worry, it's not scary. The formula for centripetal acceleration is: where is the centripetal acceleration? Is the velocity, speed of the object? Is the radius of the circular path? This formula tells us that centripetal acceleration increases with the square of the velocity. That means if you double your speed, you need 4 times the centripetal acceleration. It also decreases with the radius of the circle. A smaller circle means a larger acceleration. So, next time you're spinning around, remember the formula. It's all about speed, radius, and the amazing force that keeps things moving in a circle. Section 5. Radius of fun. How size influences the spin. Let's talk about radius. The radius is a fundamental concept in understanding circular motion. The radius is the distance from the center of the circle to any point on the edge. It's a simple yet powerful measurement that can change how we experience spinning objects. It plays a big role in centripetal acceleration. Think about a merry-go-round. The radius determines how fast you feel the spin. If you stand near the center, you'll feel less acceleration than if you stand at the edge. This is because the center has a smaller radius. That's because the edge of the merry-go-round has a larger radius, so it travels a greater distance in the same amount of time. The larger the radius, the more pronounced the effect. The smaller the radius, the more times you spin around in a given distance. This means you experience more frequent changes in direction. That means more changes in direction, and therefore more acceleration. Smaller objects with smaller radii spin faster and feel more intense. So, whether you're on a carousel or swirling a yo-yo, remember that the radius affects how much you feel the spin. The next time you're at the playground or playing with a toy, think about how the size influences your experience.
Section 6. Spinning at the speed of science angular velocity. In this section, we will dive deep into the fascinating world of rotational motion and explore the concept of angular velocity. Now, let's throw another term into the mix: angular velocity. This is a crucial concept in physics that helps us understand how objects rotate and spin. This measures how fast something is rotating, whether it's a spinning wheel, a rotating fan, or even the Earth itself. Angular velocity gives us a way to quantify that rotation. It's usually measured in radians per second, rads. This unit helps us understand the speed of rotation in a standardized way. Think about a spinning top. When you spin it, you can observe how quickly it rotates. Angular velocity tells you how many radians the top rotates through every second. This gives us a precise measurement of its rotational speed. A radian is just a way of measuring angles. 1 radian is the angle created when the arc length is equal to the radius of the circle. We can also use angular velocity to calculate centripetal acceleration with a slightly different formula: A equals r omega squared. This formula is essential in understanding the forces at play in circular motion, where A is the centripetal acceleration, r is the radius of the circular path, and omega is the angular velocity. Each of these components plays a vital role in the dynamics of rotating systems. So, if you know the radius and how fast something is spinning, you can calculate the centripetal acceleration. This calculation helps us predict and understand the behavior of rotating objects. It's like having a secret code to unlock the mysteries of circular motion. With this knowledge, you can delve deeper into the world of physics and explore the wonders of rotational dynamics.
Section 7. Hold on. Tight. It's centripetal force. Now, we know that centripetal acceleration makes things move in a circle, but what causes it? The answer is centripetal force. Centripetal force is any force that pulls or pushes an object towards the center of a circular path. It's what keeps things from flying off in a straight line. Remember Newton's first law of motion. An object in motion will stay in motion at the same speed and in the same direction unless acted upon by an unbalanced force. Centripetal force is that unbalanced force that makes an object move in a circle. It's always directed towards the center of the circle, just like centripetal acceleration. Section 8. From salad spinners to space stations. Centripetal force in action. Centripetal force is everywhere. It's at work in many everyday objects and phenomena. Take a salad spinner, for example. When you spin the basket, the water droplets inside experience a centripetal force pushing them outwards. Since the holes in the basket allow the water to escape, it flies off in straight lines. Or think about satellites orbiting Earth. The force of gravity provides the centripetal force that keeps them from drifting off into space. Even the tea in your cup when you stir it is affected by centripetal force. The spinning motion creates a force that pushes the tea up the sides of the cup.
Section 9. Centrifuges separating stuff with serious spin. Centrifuges are machines that use centripetal force to separate substances with different densities. They're used in labs, hospitals, and even some factories. A centrifuge spins a sample at incredibly high speeds, creating a strong centripetal force. This force pulls the denser materials outwards, while the lighter materials stay closer to the center. Centrifuges are used to separate blood components, isolate DNA, and even purify chemicals. They're a great example of how we can harness the power of centripetal force for practical applications.
Section 10. The science of thrills. Centripetal acceleration and amusement park rides. Ever wondered how amusement park rides provide such exhilarating experiences? You guessed it. Centripetal acceleration is the key. From spinning teacups to towering roller coasters, these rides are designed to manipulate centripetal acceleration, creating sensations of weightlessness, increased gravity, and everything in between. Think about the classic Ferris wheel. As the wheel rotates, you experience a constantly changing centripetal acceleration. This is what makes you feel heavier at the bottom and lighter at the top. Amusement park engineers carefully calculate the speed, radius, and forces involved in each ride to deliver those unforgettable thrills while keeping everyone safe.
Section 11, wrapping it up, Centripetal Acceleration's grand finale. So there you have it, the whirlwind world of centripetal acceleration. We've explored its definition, formula, real-world examples, and even its connection to amusement park thrills. Remember, centripetal acceleration is the change in velocity an object experiences as it moves in a circular path. It's always directed towards the center of the circle and is caused by centripetal force. From spinning tops to orbiting planets, centripetal acceleration is a fundamental concept in physics that helps us understand the motion of objects all around us. So next time you see something moving in a circle, take a moment to appreciate the science behind it. It's a force to be reckoned with, literally.